Mensuration Mobile, quality e-learning experience on the go.
Good day and welcome to today's class. Our topic for today is captioned mensuration of plane figures. Mensuration of plane figures. Okay. In this section, we shall consider the perimeter of a number of plane figures bounded by straight lines, and our particular interest will be on polygons. We're considering plane figures, mainly polygons. All right. Examples of polygons. Polygons are four-sided figures. And examples of polygons we have number one, we have the rectangle. Okay. Then number two, we have the parallelogram. And then number three, we have the triangle. The triangle. Okay, and number four, we have the trapezium. And number five, we have the rhombus. All right. We shall learn about properties of these planes, ranging from properties like areas. Shall be considering properties like areas and perimeters. Perimeters of these figures. That would be our interest. We'll start with perimeters. Right. And we define the perimeter of a plane figure as the distance. The perimeter of a plane figure as the distance around the figure. Okay, and this distance could be obtained. It could be obtained. By adding the lengths of the sections. All right. For example, we'll take an example so you will understand. Example one. Assuming you are told to find the perimeter of the figure below. Okay, and maybe you're given a plane figure of this shape. And they're told that this side is A centimeters, B centimeters, C centimeters, D centimeters, and then E centimeters. All right. The perimeter of the shape is equal to adding all the sides, A centimeters plus B centimeter plus C centimeter plus d centimeters, and then plus e centimeters. Okay, hence all we are saying is that the perimeter is the distance around the object. Okay, we shall consider some other objects. We shall consider objects of this form. If you have an object of this form, and maybe denoted as X, arrow, P, and Q, and then if you look at the object very well, you will find out that these sides, the opposite sides are equal. Okay, the perimeters are easily obtained. Okay, this object, the figure we have here, is an example of a rectangle. Okay, so you find the perimeter by adding all the sides and y plus y. Okay, we're looking at this. You have 2x plus 2y, which could also be written as 2x plus y, since 2 is common between the two brackets. So therefore we can say that the perimeter of a rectangle, the distance around a rectangle, is equal to 2 times the sum of the two sides. Okay, what of the parallelogram? Let's talk about the parallelogram. Okay, these have similar properties as the rectangle, but it differs. They have similar properties in the sense that opposite sides are equal. Okay, can manage this. All right, this is our parallelogram. Opposite sides are equal. You can find out that this side is equal to this, so you can say B and B, and then A and A. Okay, the parallelogram have the following labels: A, B, C, D, A and B. All right, so you see they have similar properties, hence the perimeter of a parallelogram will look similar to that of the perimeter of a rectangle. Perimeter here is given as 2a plus b. Okay, it is derived from the fact that you add the two sides, the two opposite sides, just like that of the triangle, sorry, that of the rectangle, and then you have 2a plus 2b, and then 2 into a plus b. Okay, this is how you calculate perimeter for parallelogram. We'll talk about the rectangles too. Alright, we've done that of the rectangles. The triangle. Okay, let us find out the properties of the triangles. Triangles, they have three sides. They are three-sided figures. Okay, and they can be grouped into three different types. The first type of triangle is the one called the scaling. Okay, here all the sides of the triangle are not equal. And the second type of triangles we have the isosceles triangle. Here you find out that two sides of the triangles, two sides are equal, and then the third type of triangle we have is the equilateral triangle. Okay, this is classifying them according to sides. Here all the sides of the triangle are equal. Okay, we have to consider the properties of the area and the perimeter. A triangle has this shape. This is the depiction of a triangle, and the sides facing the angles B, so you have the small letter B, and then the side facing A, so you have the small letter A, the side C, and then you have the small letter C. Okay, the perimeter of a triangle is given us just like we do adding all the sides. Okay, good. So this is how you determine the perimeter of a triangle, by adding all the three sides. Gives you the distance around the triangle. We shall take examples on finding perimeter. Example 1. You see, every other object, perimeter of every other object is derived from a knowledge of knowing how to find perimeters for these other objects mentioned. Moreover, it's not a difficult thing to do. Alright, we shall find like I said, example 1, find the perimeter of the diagram. Below. Okay, and so we have a diagram with the shape of E. Right, we have a diagram with this shape. Okay, and we are told to find the perimeter of this diagram, and here we have 15 cm. Alright, here is K, trying to level the diagram at this point, I, and here you have J, and here you have H, G, E, F, D, C, A, B. Alright, A, B, C, D, E, F, G. Okay, here you have 15 cm. This place you have 5 cm. And at this point too, you have 10 cm here. And then at the center you have 10 cm too, and this point to 10 cm, 5 centimeters, 10 centimeters, and then you have 5 centimeters, and then at this point too, you have 10 cm, and here you have 5 cm. At this point you have 15 centimeters. Alright, so how do we find the perimeter of this object? How do we find the perimeter? Alright, the perimeter being the distance around the object will be equal to distance AB we have distance AB plus distance BC plus distance CD, and then plus distance ED plus EF plus FG plus HG, and then plus you have GH plus HI, and then plus IJ, plus you have JK, and then plus you have KL plus LA. Alright, this gives you the perimeter, and then you find out that AB is 15 cm, BC is 5 cm, DC is 10 cm, AD is 5 cm, and then EF is 10 cm, FG is 5 cm, HG is 10 cm, and then GH is 10 cm too. Right, HI is 10 cm, IJ is 10 cm, and then JK is 5 cm, KL is 15 cm, while LA is 30 cm. Alright, we'll continue the next slide. LA is 30 cm. So we try to add the values together. When we pick the values of 10, we have the next slide. If you do our computations very well, we'll have the next slide as 50 after picking the value of 10 plus 65 plus 15. Alright, 65 plus 15 will give you 80, and which will give you 130 cm. So therefore perimeter of the object is equal to 130 centimeters. Alright, with this I believe the concept of perimeter has been dealt with. We'll be talking about areas. Okay, the areas of these polygons we have described about. Areas of polygons are often expressed as the sum of rectangles or triangles, and so we shall illustrate them as we discuss. Alright, the first object we'll be talking about, the first figure we'll be talking about here is the triangle. The area of, the rectangle. Okay, the area of a rectangle. Area of a rectangle is given as the product of the two sides, okay, which is as well written as LY. In your primary school we used to say length times width. Okay, but that's the area. We shall also define area for the triangle. Areas and triangle. how do we determine the area of a triangle? Here we shall use objects for our illustrations, and then we shall make two derivations at once. Assuming we have a triangle of this form, and then we have another triangle of this form. Okay, you should know that all I just did was to bring in two triangles, one having this nature and the other triangle. Okay, all right, combining these two triangles, we give you a parallelogram. Okay, which we just obtained. We give you a parallelogram, and so this is our triangle, and this is another triangle, for which if they are joined together they form parallelogram. Parallelogram, we can denote the sides with C. I mean, if you start from this point, you have AB and CD. Okay, so we like to move to the next slide so that we can have a clearer view of what we're talking about, and then I can affix my triangles again. Another triangle, and you have C, A, and then I have B. Okay, and A again, because remember these are two triangles joined together. Okay, all right, so from this point we affix a line to denote the height of the parallelogram, and we can denote the point where the line meets as D. All right, so we define the area of a parallelogram. Area of parallelogram to be equal to these places outside C, B, and A. Okay, area of the parallelogram to be equal to the base C times H. We'll explain further. Where C is where C and H are the lengths. They are the lengths AB and CD. Okay, we'll go ahead having this in mind, and then determining the area of the enclosed triangle, the triangle inside the parallelogram. And therefore we have area of the enclosed triangle. The triangle we have there is ABC, which is defined as half CH, right? Which can also write as half BC sine A. Okay, if we have a missing side, or if we have one of these triangles we mentioned and we wish to find the height, okay, and we can write as half AB sine C, which we can also write as half AC sine B. Okay, this gives us the formula of the triangle rather. Since a parallelogram is equal to 2 times a triangle, okay, from the diagram we can also define the area of a parallelogram alright to be equal to 2 times area of a triangle. Okay, which is as well given as 2 times half CH. Alright, and this cancels this so that you have CH. Okay, just like we had above at this point and then at this point. And so there are other methods for finding the areas of a triangle. The areas of a triangle can also be found using the Hero's formula. The Hero's formula for areas. I mean, area of a triangle. Alright, the Hero's formula it states that provided all the sides of a triangle are known, it is used if and only if all the sides of a triangle, we know all the sides of a triangle, okay, we can use the Hero formula. The Hero formula is given as area of a triangle to be equal to square root of x minus a and times x minus b times x minus c, x a, b and c being the sides of the triangle, where x is determined by half of all the sides. Alright, this is how you find the value of x. Okay, assuming we take for instance an example and you're told to find the area of the triangle, for example. You're told to find the area of triangle x, y and z, and maybe you're given this triangle below. I wish I can get this. Alright, and here is our x, here is our y, and then here is our z. Okay, and then here, which you know so well, is the base 10 cm, 6 cm. How do you find the area of this triangle without being given the height? We are not given the height of the triangle, and you know the height of this triangle should be at this point. Alright, so h for the diagram, how do you find the h solution? Remember that the area of a triangle is given as half base times height, okay, you know, which could as well be obtained by doing as follows: half base times where h is missing, you can have half base times a sine b, or any of the relations as we stated. Now, how do we obtain a sine b? Alright, a sine b is obtained in the sense that since you have the two sides and one side is missing, to find the height you will use the one side you've been given to obtain it. Okay, good. So which means you have 1/2, and the base there is 10 cm, and the one side you've been given is 6 cm. Alright, there is also an angle. You know, if you're not given a side, you must be given an angle. And then sine B means sine 30. Alright, if we want to write this formula in the relevance of the equation, okay, we shall write as half y times half y times z sine x, z sine x. Alright, so so that it will be for this equation. Okay, and then 2 goes into 10. Here you have 5 times 6 sine 30. Okay, you can use your calculators to evaluate for sine 30, and sine 30 is equal to, when you punch it on your calculator, sine 30 is equal to half. Okay, and so this means 5 times 6 is 30 times half, which will give you 15 cm. And after computing your areas, you have to leave your answers in centimeters squared. Okay, for the case we have the height of the triangles, had it been we were given the height of the triangle, okay, the height of the triangle is known, we will simply find the area of the triangle simply, okay, by just this, bringing the base, multiplying the height. That's all. I can take a second example, example 2. Example 2 here, told to find the area of the triangle. PQ and R. Okay, and here you're told that PQ is equal to 5 centimeters, and the rest of the parts, PQ 5 cm, the rest of the parts are given as 6 and 7 centimeters, and they could be RQ 6 cm, and then you may be given as well PR to be equal to 7 cm. And so if actually we have a rectangle of that form, and you're told to find the area of the rectangle, if I should name this for P, Q and R. Okay, and then I have PR 7 cm, RQ 6 cm, and then PQ is 5 cm. Okay, so if these are the sides of the triangle, so we can say since all the 3 sides are known, we can apply the use of Hero's formula. Okay, solution by Hero's formula. Okay, we first of all determine x, which you have been told is equal to half of all the sides a plus b plus c, which is equal to 1/2. Okay, you can use a as 5 plus 6 plus 7. You know, this a plus b plus c you can as well write as half of p plus r plus q. Okay, and so x is equal to, when you add the 3 digits here, you will have 7 plus 5 gives you 13, sorry, gives you 12 rather, and then 12 plus 6 gives you 18, so you have 1/2 and 18, so that x is equal to 9. And then how do we find the area of triangle? Area of the triangle is now equal to the square root of x into a, x minus a, x minus b, x minus c. Alright, which we can as well write as this: x is 9 minus a, okay, 9 minus 5, 9 minus 6, and 9 minus 7. And then on the next slide we have this 9 minus 5 gives you 4, minus 6 gives you 3, and minus 7 gives you 2. Okay, so we have that area is equal to square root of 9 times 4 times 3 and times 2. Okay, and so that leads us to square root of, when you multiply all these, you have 216, and when you take square root of 216 you have 14.7 centimeters. 14.7 centimeters. We'll take an example for the parallelogram. Take an example for the parallelogram. Example for the parallelogram. Okay, assuming I call this example 3, and you're told to find the area of the parallelogram below. Okay, and you are given a parallelogram of this form. Alright, and then at this point you have the parallelogram subtend an angle of 30 degrees here, and then the base is 16 centimeters. You have 12 cm at this point. You have D, C, A and B. Okay, so how do you find the area of this parallelogram? Remember what we said, that you should note that a parallelogram is equal to 2 times a triangle, and so therefore the area of a parallelogram is also equal to 2 times the area of a parallelogram. Okay, so here we'll be talking about, therefore, area of parallelogram is equal to 2 times area of triangle. Okay, and so we're only saying that this is 2 times half base times height. Okay, and for this our height here, for this, if this were to be our triangle, for this our height here will be given as, assuming another line runs to divide this as a triangle, then the height here will be equal to 12 sine 30 degrees. Okay, the side you have, and you know here is also 12 cm. Remember what we said about the parallelogram, 16 cm too, and so using the side and the base, okay, that gives us 12 cm. Remember, a parallelogram is 2 times a triangle, so that's why we have that. So we can say 2 times half base, the base there is 10, and then the height there is 12 sine 30. Alright, and over to the next slide. which leads us to the fact, okay, what we had previously is to have 16 times 12 sine 30, and sine 30 we know to be 2.5, right? 2 can take care of 2, and then you have 16 times 12 times 0.5. all right, this house this, and then you have 16 times 6, which gives you 96 centimeters squared. Okay, since we have done some works on 2 sides, okay, let me give a heading, the trapezium. all right, for the trapezium you have a figure of this nature. Okay, and if I denote the side as SRPQ, and then distance between these two spaces is the height. A line that runs through the trapezium to divide it into 2 is called the diagonal line, or the diagonal. all right, properties of a trapezium. Properties, let's look at properties of the trapezium. Number 1, they have just like we've seen from the diagram, they have 2 different sides. It have different sides, x arrow and PQ. okay, from the diagram you see that the sides are not equal sides. Number 2, the distance between the sides, is the height of the parallelogram, the height of the trapezium. all right, and the area of the trapezium, is given as the sum of the areas of triangles PQX and triangles QRX. all right, look at what we are saying. When the diagonal line divides this into 2, you have triangle PQX and triangle QRX. You have 2 different triangles with different size lengths. Therefore area of triangle PQX, okay, which is half. all right, let's go back so we can denote them very well. all right, so this can be called small letter Q, this is X, and the diagonal line for this is P, and then these 2 can be called small letter Q, and this is X, and then the diagonal line could be P or R, depending on the triangle you're considering, because we have 2 sets of triangles here. We have this divided by the diagonal line, and then we have these 2 divided by the diagonal line, and then we have X arrow and Q, and for this we have Q, P and X too. Just from this diagram you can obtain this. So all we are saying is that the areas are given as have an edge, and the other area of triangle QRX is given as half base times height, b and edge, okay, where a and b denotes the sides, okay, and the height, okay, the two different sides that are not equal, and the height, so that joining the two together, area of trapezium PQRX will be equal to adding them together, half AH plus half BH, which is equal to, picking like terms, H A plus B. Having known this, we'll go into solving some examples. Our first example on the trapezium takes the following form. It says example, okay, and in a trapezium PQRX, the sides PQ and XR parallel, okay, and then PQ is equal to 40 centimeters, XR is equal to 30 cm, okay, and the distance between PQ and XR is 10 cm. Now you're told to calculate the area of the trapezium. Alright, so how do we go about this? The solution takes the following form. You can give a pictorial diagram of the equation, okay, you can manage this, X, R, and then that's my Q, and then P, and you're told that XR is equal to 30 cm and the PQ is equal to 40 centimeters, and then the distance between PQ and XR, which is the height, is equal to 10 cm. So how do you find the area? Remember that area is defined as half of the height times both the sums A plus B, okay, where A plus B could be replaced with half height times XR side plus PQ side, okay, and the height there is 10, XR there is 30 plus 40, okay, it gives you 5, 30 plus 40 gives you 70, and so 5 times 70 is 350, and since they're in centimeter, area is always in centimeter square. We'll take another example, and I'll call that example 2. Example 2, and you're told a piece of cardboard is of the form as shown below. Okay, so when we see it, we are told to determine the area of the cardboard. All right, so the cardboard is given as this. Okay, and then this is the picture we are talking about. This is the height. Another picture, and the angle it sustains here is 45 degrees, and here you have an angle of 60 degrees. All right, you have P, you have X bar, and you have X, you have R, and you have R bar, and then you have Q here, and you're told that the length here is 20 cm, so virtually the length here too should be what, 20 cm. Okay, and you're given a side 10 cm. So the question says determine the area of the cardboard paper. Determine the area of the cardboard paper. Solution: there are sides we need to determine before we can be able to find the area of the cardboard paper, and they include sides like this. You can call A and B, and we need to find the value of H before we can be able to determine the size of the cardboard paper. Now, how do we go about finding the value of H? We shall assume this to be a triangle, okay, and then applying principles of trigonometry. Okay, where you have that when you have a hypotenuse side and an opposite side, you can say that you can use sine theta to be hypotenuse, alright, is that hypotenuse, sorry, it should be opposite x, and x bar opposite over hypotenuse px. Okay, we are saying this implies that sine theta, which is sine 60, is equal to opposite, which is h, and then the hypotenuse 10. Alright, from that point we have that h will be equal to 10 sine 60 degrees. Okay, you know, when you multiply out, making h the subject of formula, you will have this, and so therefore h will be equal to if you punch this with your calculator, you will have that h is equal to 8.66 centimeters. So the height is 8.66 cm. Alright, so having determined the height, we need to find the parts. Finding the parts px. Okay, remember that when you have a triangle and you have two sides, you can use Pythagoras theorem, and so to find this part we will apply Pythagoras theorem. Alright, so, and the theorem states that px all squared is equal to x all squared plus px all squared. Alright, and it follows from the next slide that from the diagram, px is 10 squared. 10 squared is equal to 8.66 squared plus px bar squared. Okay, so all we have to do is to make px bar the subject of formula, and so it means moving the rest of the equation to one side. Okay, and so px bar will be equal to 100 minus, when you square this you have 749956, and so px bar is equal to 25 when you carry out your subtraction very well, so that these are all squared. Alright, so that px of its own will be equal to the square root of 25.0044, so that px itself will be equal to 5.0004, right? So therefore we can take px to be equal to 5 cm. Right, and so we have finally determined some parts in the diagram. Okay, we have finally determined some parts in the diagram, that this part px bar is 5 cm, and then here is 10 cm, and the height itself, h, is equal to 8.66. and so remember we have an angle of 60 and 45, 60 at this point and 45 at this point. Okay, since the height is 8.66, so the same height applies for this, so they will be equal. And then we have 20 cm to be the, and this will be 20 cm too. All we are doing is to find the length of this side, so that when we add them together we can be able to determine the area of this trapezium. And so how do we find the length here? The length we are yet to find is the length RQ, and so hence we'll determine RQ as well using the principles of trigonometry. RQ, you see the sides we are interested in are the adjacent and the opposite side, and tan theta is equal to adjacent, and the adjacent side there is the adjacent side there. Alright, the denotation is okay, and the adjacent side is R bar Q, and the opposite side, that's the adjacent side, and then the opposite side is RR. Okay, that's the opposite side. So therefore that tan theta will now be equal to opposite of adjacent, which is R bar over R bar Q. Okay, and theta there is 45 degrees, and RR is the height, which is 8.66, and RQ is the part which we intend to find. So if you carry out your subject of formula very well, you have that RQ is equal to 45 degrees, which is equal to 8.66, so that RQ on its own will now be equal to 8.66 divided by tan 45 degrees. And so therefore if you carry out this computation, you have that RQ is 8.66. You know, that is to say that tan 45 is equal to 1. Therefore the length of the opposite side of the trapezium, which is PQ, will be equal to px bar plus x bar r bar plus r bar q bar, sorry, plus r bar q. Therefore, which you have that here, p25 plus 20 plus 8.66, which are the sides we determined, and so you have 33.66 cm to give you the total side here. So PQ here is 33.66 cm, because we have this side to be 8.662. Alright, and so since we have that side PQ and we have this side XR20, we can go ahead to determine the area of trapezium, and therefore the area of trapezium area of trapezium, which is equal to 1/2 of the height and plus the sides. Okay, where the sides are the PQ, 1/2 of the height PQ plus XR. Okay, which is equal to 1/2. The height there is 8.66, and the PQ plus XR is 33.66 plus 20. Okay, and so this gives you 1/2, 8.6. So we are saying that the rhombus is a parallelogram whose adjacent sides are equal. Okay, the rhombus is a type of parallelogram whose adjacents are equal, and then we can denote the rhombus with the diagram above, having equal sides. Okay, has the shape of a kite. Alright, so all we are saying is that these sides are all equal. So if you draw a diagonal line across the rhombus, okay, this diagonal line shares the rhombus into two, and these two, from whatever part you pick a diagonal, it shares the rhombus into two. So if I should denote this as x/2, this part, no, because this is half of this diagonal line, and these two as x/2, and if I should denote these two as y/2, okay, and then these two as y/2. All right, so something we should note about the rhombus is this, that a square is a special type of rhombus. Okay, it's a special rhombus, and so it have two equal sides. Okay, it will have, I believe it will have two equal sides when a diagonal line crosses through it. Alright, when a diagonal line crosses through it. Okay, alright, this is just to help you out in what we are doing. And so how do you find the area of a rhombus? The area of a rhombus is obtained by multiplying and adding the diagonals. Okay, so when you multiply and add the diagonals, you have the area of the rhombus. Alright, to be equal to 1/4 xy plus 1/4 xy. Alright, all we did was to multiply these diagonal points on this one line, and then to multiply these diagonal points on this other line. Okay, and when you do that, you have x/2 times y/2. Okay, for this, and then add it to the other one, you have x/2 times y/2, okay, which will give you xy/4 plus xy/4. All right, that was just what we simply did to obtain the area of a rhombus as this. And so we'll pick an example. Example on rhombus, example 1. Okay, do not bother about the perimeter of the rhombus because it is just the distance around the rhombus, for which you just have to add the sides AD, DC, CB and AB together to get the perimeter of the rhombus, just like we discussed them previously. Example, in a rhombus, okay, one of the diagonals is 1 and is 1.5. Sorry, 1.5 times 1.5 times as long as the other. Okay, the other diagonal. Alright, now if the shorter diagonal if the shorter diagonal is 6 cm, alright, find the area of the rhombus, sorry, that's rhombus. Okay, so how do you go about this? We'll take a solution from the next slide. Solution. Alright, we have to note that length of the short diagonal is equal to 6 cm. Okay, and then length of 1.5 of the short diagonal, that is 3/2 of the short diagonal. Alright, that will give us to be equal to 3/2 times length of the short diagonal, which we give 3 times 3, okay, 9 cm. So therefore the long diagonal is 9 cm while the short diagonal is 6 cm. Hence we cannot find the area of the rhombus. Okay, the area of rhombus, which is equal to like previously we said, xy over 4 plus xy over 4. We can also shorten this to be equal to 4, and so you have xy plus xy. Okay, so you have 2xy over 4, and so you can shorten the formula to be equal to xy over 2. Alright, so where our x for this is equal to 6 cm for the short diagonal and y is equal to 9 cm for the long diagonal, so that if we use the new derived formula for rhombus, for area of rhombus, we will have this xy over 2 to be equal to 6, 9 over 2. Alright, the next line follows. 6 times 9 is equal to make things easier, we can divide out 6, and then we'll have 3 times 9 to be equal to 27 centimeters squared. So therefore area of rhombus is equal to 27 centimeters squared. Alright, so these are the basic polygons we have, and we've described them. We've mentioned how you can work on them. Thank you for being part of the class. They come up next time. Study so that you can follow up in the coming classes too. Have a great day.